Solving linear equations. What on earth does that mean? Well, let's think about each word individually. Every word in mathematics means something. To solve means that we're going to find a value or a number, a real number. We'll put real number since we're in the real number system. Find a value, that is a real number, for the variable that when we use this number, the equation is true. So we're going to find a value for the variable that makes the equation or statement true. That's what we're doing. That's all we're doing, really. What about linear? So that's solving. A linear equation, well, you might think of the word line. That would be a graph, right? But in a linear equation, we're really looking at the variable, say x, or it could be y, could be t, whatever the variable name is really immaterial. What we need to have is it needs to be raised to the first power. That's what makes it linear. If it's y squared, if this were our variable were y squared, we'd say, well, that's not linear, right? If it were something like the square root of t, we would also say that's not linear either. But certainly we could have something that looks like z. No problem. That's what makes an equation linear, and an equation is basically something that's, you can think of it as being balanced. This little squiggly line I use just basically defines, is sort of a definition squiggly. That's the technical term. So equation would be something with an equal sign in it. I'm going to put that in quotes. Right? We have two sides. It's another way to look at an equation. It's basically balanced. Alright, so we're going to solve these. I'm going to do this with an example. First of all, let me give you the steps, and I'll go through each one of these steps one at a time. We're going to get everything into terms. Remember what a term is? Right, separated by addition. We're then going to combine like terms on each side. Sometimes these two processes together are called simplifying both sides. Simplifying both sides. All right, that would be 1 and 2. 3, we're going to move, and I put that in quotes, we're going to move variables to the left and to the right, and I should say variable, perhaps I should say terms with variables in them to the left, and constants or numbers to the right side of the equal sign. So we're going to put all the variables on one side and all the constants on the other side. We'll do that by adding or subtracting on both sides. Then we'll again combine like terms if needed. And finally, we're going to solve for the variable, and we'll do this, I'm going to show you a way by multiplying both sides by the reciprocal of the coefficient. Reciprocal? What's reciprocal? Reciprocal, what does that mean? It's 1 over, right? Or I take a fraction a over b, and I would say its reciprocal is 1 over a over b, or I would just flip it, b over a. Right? So we're going to take the reciprocal of the coefficient. What's a coefficient? A coefficient is the number in front of the variable. So perhaps I have 2x, the coefficient here, is 2. If I had something like negative 1/2 x, the coefficient would be negative 1/2. And let's also remember, this is the same as negative x over 2, or x over negative 2. And when you think about this, I want you to remember that this multiplying by negative 1/2 is the same as dividing by its reciprocal. So here I'm dividing by negative 2. Here I'm multiplying by negative 1/2, and we end up with the same result. This particular step, step 5, is sometimes called isolating the variable. Great. Let's look at an example. This is a nice example. It's quite a bit, it's a little bit of a mess, but I think we can get through it. So the first thing I want to do is get everything into terms, and as you can see, I've got a 2 times 2 terms, 3x plus 5. So I need to distribute the 2. I'm going to distribute this 2 to the 3x, and I'm going to distribute this 2 to the 5. The second set of parentheses that closes the parentheses says that's as far as I'm going to go with that 2. I'm not going to multiply the 2 by the x. So on the left hand side, I'm going to have 2 times 3, or 6x, plus 2 times 5, which is 10, and then I'll keep that plus x. Now I've got 1/2. This 1/2 is going to again multiply to the 2 and to the x only. It won't affect this plus 5 because the parentheses finished it or closed it off. Okay, so 1/2 times 2 is 1. 1/2 times x, that's just going to be plus 1/2 x, and then I'm going to have plus 5. Alright, so this is where we left off. Now we're going to combine like terms on each side, because you'll notice on the left hand side I have 6x sitting here, and I have a plus x. Both of those have the same variable factors. 10 doesn't have x next to it, so I can't do anything with that, but I can take 6x and add x to it, so I get 7x plus 10. 10 will just sit there. And that equals, and I look on the other side for what is common. Well, I've only got one x in the middle. I've got this 1/2 x, but I've got the number 1 and I have the number 5, and those two things can be added together, so I get 6 plus 1/2 x. So now I've combined terms on each side. Let's go on to the next step. Alright, here I'm going to move the variables to the left and the constants to the right. So my variable is x. I have a 7x on the left. I need to move this 1/2 x away from this side, so I'll subtract it and I'll add it over here. So I'm left with 7x plus, minus, getting ahead of myself, I have to step through these things. So I have minus 1/2 x. So now I have 7x minus 1/2 x. And then I'm going to also subtract this 10. I'll do that in another color. So I'll subtract 10 from both sides. And that will essentially move this 10 to the other side. Notice this term cancels out or adds to 0 on the right, and on the left the 10 and minus 10 also do. So I'm left with 6 minus 10. Great. Let's move on to the next step. Alright, the next step says I'm going to combine like terms if needed, and certainly you can see that we do need to. I'm going to change this. Instead of saying 7 minus 1/2 x, I'm going to make that 14 over 2 so that I have a common denominator, which is what I need if I'm going to add fractions, right? And I'll go ahead and do this side. The right hand side would be minus 4, correct? 6 minus 10. You can, if you would like, think of that as 6 plus a negative 10, right? So 14x minus 1/2 x, 14 over 2x minus 1/2 x will give me 13 over 2x, and that will equal minus 4. Now we need to isolate x. I'm not looking for 13.5 x. I really want just x by itself. So let's try that. 13x over 2 is equal to minus 4. And again, remember I said we're going to multiply by the reciprocal of the coefficient. And our coefficient in front of x, what's our coefficient? Our coefficient right now is 13 over 2. So its reciprocal is going to be 2 over 13. So I'm going to take 2 over 13, multiply that by the left-hand side, and the right-hand side, well, if I do something to the left-hand side of an equation, I have to do the same to the right. So I'm multiplying. I'm going to put these parentheses on the right so it's very clear that I'm multiplying and it's not 14 and 2/13. Alright, so if I multiply 2/13 by 13 over 2, I essentially get 1. This is equal to 1. So I have 1x on this side, x, and that is equal to minus 8 over 13. And that would be our answer.